We're going to make 2 columns. Remember what the 2 columns were yesterday when we were testing the iPod? Exactly. Data and expected, right? Good. Beautiful. If you don't mind, I'm going to call it observed and expected, but data is observed. It's exactly right. Now, the only reason I'm going to put an O there, the program I gave you, that I wrote for you, has the word observed in it. Data is actually a better word to use. It's just observed is kind of colloquially used. All right, here's the numbers we got. The numbers we got. Brown, we got 177. Red, we got 169. Orange, we got 258. Blue, we got 297. Green, we got 193. Yellow, we got 168. That gives us a grand total of tested candy of 1,262. Well done. Frankie, this is why I wanted to look at more. I want to look at more. I want to combine our data together to get that number. Because as you guys noticed, your individual bags didn't look right. Like I'm looking at Danielle's, and she's got the fewest brown, actually the fewest brown and red, but yellow came in pretty small too. But the problem is that yellow is so close, 13 and 14 are so close together, that a small sample like that is going to not be able to distinguish between them. I mean, it looks like you go brown, then yellow, then red, where it should go brown and red, then yellow as far as increasing probabilities, but with a small sample like that, you really can't, it's too tough to tell. So, what we're going to do is we have to figure out what we should have seen based on the percentages that Mars gave us. So this is data, and this is population, if Mars is correct. So how are we going to figure that out? What do you think? What should go in the E column for brown? Austin, go.
Take the total, whatever it should be.
Exactly. We know that there were 1,262 total candies, yes? What percentage of them should have been brown? 13%, yes? So take 13% of that. Excel tells me that should be 164.06. Double check me on that. Double check my math, if you would. Excel should be correct. I just want to make sure that I'm doing this right. Red, we should have had also 13%. So that should also be 164.06. Let me make sure Excel's got the right calculation. It does. We're good there. And then we just apply the percentages all the way down. You want to make sure you do this. You don't want to plug the percentages in there, because you have observed counts and expected percentages. That's apples, oranges. You have to make sure you're comparing counts to counts. Does that make sense? You could also compare, I imagine, percentages to percentages using a different distribution. But counts to counts is what chi-square test scores. Orange is 20%. That should be 20% of 1262, which gives us 252.4. This was much easier back in the day when they had the distribution that all ended in zeros. Green is 16. Did I put that in the right place? I did. Green is 16%. I don't know why I just jumped down here. That is going to be 201.92. We'll go back to blue. Blue's 24%. And ours came out the most too. And that ends up being 302.88. And yellow, 176.68, because yellow is 14. I forgot the number I said was already. 176. 176? 176. 168. Which will all sum to the same 1262 that we summed to over here. It's going to be just fine. Why didn't we do this yesterday with the iPod? Or Tuesday with the iPod? Do you remember doing this with the iPod? This whole multiplication? Good! Alex says, yes, we did do it. We just didn't write it out. Why didn't we write it out on Tuesday? Because it was easy to do in our head because they were all the same. If you have 10 songs on an iPod on random, they should all happen 10% of the time. And you guys did it in your head. There were 50 songs played. 10% of 50 is 5. So you actually did do it. You just didn't write it out because the distribution was easier to use. That's what's so cool. goodness of fit works whether the distribution is uniform, like the iPod or like Skittles, or if it's not uniform, like whatever you want to call this M&M distribution. Fair enough? All right. So at first look up at the graphs. Do the graphs look like they're ish in the correct place they should be if the Mars percentages are correct? Ish. It does look like that. It does. Blue is arguably the highest, although it's close to orange. But orange is supposed to be second highest, I think, right?
Yeah.
Yeah, so this is looking close. So let's see if it's close enough to not arouse suspicion. Yeah, green should be, green's the 16%, so that bridges the gap between blue and orange. And these are the three low ones, and they look kind of where they should be, yes?
What's the top color?
Brown, yes, that's brown. Brown and red should be tied. They look like they roughly are. There's definitely sampling error, of course. But now let's test for, let's get rid of the sampling error and make it one big old margin of error for the test. Beautiful. Good so far? Love it. All right. Let's shut this down and go to the machines. Go to your TIs now. Actually, I have the test done on Excel, but you can't see what I'm doing on Excel. Unfortunately, it won't make any sense to you. Go ahead, Nick.
I just put it.
Can we start? Oh God, yes. Please eat now. Eat. The data's been collected. Manja. Yeah, manja. Of course. Sorry about that. Just want to make sure you count it before you enjoy it.
So we're on number 6, right?
What was 6? Pick the distribution?
Yeah.
Yes. And what distribution are we picking? Chi-square. Interesting non sequitur about chi-square.